let's get started. So let me using this thing. All right, good evening, everyone, and welcome to Kubernetes and Cloud Native NorthDallas. I hope everyone is keeping safe. So these days, we can only meet online. There won't be much of networking as we used to do, but at least we can continue to learn and engage with our community. So nice to see all of you. So we're going to get started. So as you know, this is one of the largest meetup in Dallas at the moment. We're somewhere around 1,600, and we talk everything Kubernetes, Docker, microservices, cloud native. Basically, we're part of the Cloud Native Computing Foundation, the CNCF. So we're a worldwide meetup group. And for this group, we meet every third Wednesday of the month. All right, meet our sponsors and hosts. So you know Brent Langston. He's a senior developer advocate at AWS, and he's not here with us today. And today we have Himansu Patel, who is a digital transformation leader at Aventive Technologies, and my humble self, Damien Igbe, and I'm the CTO of Cloud Technology Experts. So today we have our sponsors. I believe the company is headquarters in California. However, our presenter is international. She is based in Canada, so I think she will introduce herself later on, and maybe then you get to know her more. All right, so her name is Deepa Kuna, our presenter, and she's from the company X Matters. And that's me again, so I'll be presenting later on. Today we actually have two meetup presentations. First will be Deepa, and then the second will be me presenting. And about Cloud Technology Experts, the main sponsor for this meetup, we basically do training. So Kubernetes administration, security, microservices, and AWS training as well. And shortly, we're going to start a presentation from Kuna, but just some announcements. Normally, we like to get people involved. So if you have a topic to talk about, always let us know. And so we're always looking for speakers. The next meetup is going to be on September 16th, and it will either be online or it will be both online and in class, depending on how things goes. So we aim for two speakers going forward, and that is what we're doing today. So even if one of the presentation is a little bit, on the high-level side, we'll try to make the other one a little bit deeper and technical so that people can gain by coming to the meetup. Okay, so this is the speaker profile. Our speaker tonight is Deepa Kuna. She's a QA architect with X Matters, and the topic of the presentation will be executing end-to-end tests in Kubernetes. And this talk may be about 30 minutes or between 30 and 45 minutes, depending on the level of interaction that we have. So now I'm going to hand over to Deepa, who will take on the presentation from here.
Hello, Damien, can you hear me?
We can hear you.
Yeah, awesome. So thank you. Let me share my screen. So, Damien, if you could accept my share.
Okay, 1 second, please. Do I need to accept it?
Yeah.
I can't see. I can't see any place accepted. Let me stop sharing. Okay. Okay, you can share now.
I've already shared. You have to show it, I believe, or approve it. Yes, now my screen
All right.
is
Cool.
okay. Okay, I've switched to presentation mode now. Is it looking good?
Mm-hmm.
Okay. So thank you everyone for joining this evening for a discussion on how do we can execute end-to-end test in Kubernetes. And thanks Damien and Himanshu for this opportunity to share my experiences. Before we get started, let me give you an introduction about myself. So hello everyone. I am a QA architect at XMatters. I have been with the company for 12 years now. This is my 13th year working for the company, where I started off as a performance testing engineer doing a lot of performance load testing, trying to see how I can break my application. And that's what QAs love to do, right? They break applications. And that's what I did for 2 years. Then I took on a lead responsibility of setting up an offshore outsourcing testing team, which basically helped us in executing manual regression testing for our release cycles. And as part of those experiences of working with different teams, I moved on to a role of a QA architect, where I took on leading a lot of process improvement initiatives of how we can deliver quality service to our customers. My passion is basically quality end to end, and I'm always looking out for opportunities of how we can build and expand our automation coverage, and how we can improve our testing processes and make it more efficient and effective. And recently, I have looking into of how I can share my knowledge and experiences with the larger QA community, because I think the more we share, the more we learn, and basically expand my experiences where people can also take the benefits of our learnings. I have 2 kids. They are 8 and 10 years old. I love baking with them. I am a pure sci-fi movie buff, and my favorite superheroes is Spider-Man, and I love and Star Trek. Sorry, I'm not a Star Wars fan. I know a lot of the people in North America are Star Wars fan, but I am a pure Star Trek fan. And yes, I am based from an Indian origin. So, as all Indians, they love to dance on Bollywood tunes. And that's what I love too. And this is, I think, Damien tells me I am a first presenter from the international border. So, I am based in Canada, Victoria, British Columbia, the paradise of Canada. So, we've got great weather all throughout the year. Hard to imagine that we barely get snow, probably a day or two. But when we do get it, it's a complete lockdown. But I'm really blessed in this scenario to live on an island. So moving on, let me introduce what we do at XMatters. Our mission is basically we provide an incident management platform to our clients, where applications who have digital services and they're looking for a communication platform to manage incidents and collaborating different applications. That's where we come in. We have offices based in in the US for basically our sales at corporate offices, and we also have a presence in Europe, London, and in Australia too. Our engineering operations is purely carried out in Canada. We have 3 locations: Vancouver, Victoria, and Montreal. And recently, as part of our transition of going into the DevOps world, we did a big architecturing of our architecture into microservices, which is what I will talk about in my next slides, and how that transition helped us to evolve into doing a lot of things in Kubernetes. So let's talk about the journey that we had. what we had to do as part of journeying from a big monolithic architecture that we had, where we had one VM that was deploying and learning, it was not scalable for us, and also definitely not scalable and cost effective if you want to run that application on a cloud infrastructure. So in order to move our entire test infrastructure to the public cloud and make it more effective, we had to look in how we can containerize our software application. So that's the first thing that we did. In order to do that, we had to retire a lot of our legacy features that were catered to work only on a VM instance. And we kind of did a lot of collaboration with our customer success teams to talk to our customers to understand what features they don't use and basically try to remove them and become more modern. We looked into how we can adopt DevOps principles within our organizations and brought in a lot of site reliability engineering practices. In that process, we also built an in-house chaos engineering tool. I'm not sure how people are familiar with different kind of chaos engineering tools that are available, like Pumbaa, Chaos Monkey, but we decided to build our own, which is Cutulu. And Cutulu is basically an application that helps to randomly shut down microservices so that we can understand the resiliency of our application. And if you're interested, here's a link to the repository. I highly recommend you downloading and checking out. This is the first application that we open source within Next Matters. And as part of this process, we also built a very scalable CI/CD infrastructure. So we actually moved our entire Jenkins infrastructure to Kubernetes. So let's talk about what is a traditional test infrastructure prior to this Kubernetes world. So we know that lots of companies who are working on the UI automation are always using Selenium as a framework for automation. And we in XMatters also use Selenium for our automation framework. And we typically had a setup where there was a VM that was installed, and we were running those tests against those VM infrastructure that was laid down. And it had the similar typical problems that we have. Poor scalability, static configurations where we cannot change things. We had to always do manual updates. Poor resource utilization, that means a VM is also always running constantly 24/7, even though your test is not running. So basically, if you are moving this kind of infrastructure in a cloud paid environment, you're paying a lot of money for resources that you're not fully utilizing. And definitely poor stability. So I think all these kind of traditional issues that we had with VM kind of infrastructures, Docker containers, and microservices have catered and brought into ways of how we can overcome these limitations. And obviously, high maintenance cost. So what are the new requirements? The new requirements in the world of cloud computing is stability in the test infrastructure, scalability in test execution, efficient resource utilization, and lower operating costs. So that with all these new requirements, it made us wonder, like, if we can run an application in a Kubernetes infrastructure, why not try running the tests also in Kubernetes? Why does the test have to be running on a traditional infrastructure? Why can't test execution be also modern? So that basically triggers the idea of looking into how we can execute tests in a Kubernetes framework. So what does it take to run a test in the cloud? First, we need a scalable Selenium grid setup so that we can run our UI automation tests. Next, we need to build a test container image that we can deploy in the Kubernetes framework to actually run our tests. We need a mechanism of how we can publish the test results so that we can view once the test is executed. And last not least, but we need to know how we can deploy those containers. Let's take a look at each of these phases and steps. So for Selenium grid setup, the first thing that we looked into is a framework called Selenium. Selenium is an abstract layer over Selenium. It uses Dockerized Selenium browsers and a node, and you can run this entire infrastructures on a Kubernetes. It has a Helm configuration that you can check on the website. What it typically does that every time you request or start a test, it actually brings up a Dockerized Selenium browser, and once the test execution is done, it actually tears down the browser. So basically, you are not running the resources, like you don't have 3 or 4 applications running all the time. So you're only bringing up the browsers when you need to run the test. So if you need a browser, like say I only need to run the test on Chrome, it will only instantiate the browser to run the test on Chrome. And if you need Firefox, it will only do that. So basically, it is an optimal resource utilization, and it keeps everything clean and it's scalable. So that's the first step that we did. We used Selenium to basically set up our Selenium grid in the Kubernetes infrastructure. Then we looked at how we can package our tests that we write in Java. So in Xmatters, our automation framework is basically Java test ng. So we have a Java based in a test ng format. So first, what we needed to build our test container image is we took a CentOS image. We installed our Java packages in defining a Docker container. We defined what files we need to actually run our tests. So we copied all our images, our resources, our drivers that we need, for example, a driver to talk to a Selenium, all those drivers and all that, we copied it into a container image. And now we need a step of how we can run those scripts. So in order to run those test suite, we defined a shell script where we define how we want to execute the test. So let's take a look what that file contains. So as you can see, it's a simple bash script where you specify the list of test suites that are available. You specify the Java command of how you want to run the test. And last step, as you can see over here in the end of the script, is after all, once your Kubernetes is done the execution, the Kubernetes will destroy the pod. So how will I view my test results? So what we did as part of viewing the test results, we pushed all this data. We used a Google Cloud Bucket because we were using Google Cloud Bucket for our entire public infrastructure. So we used GCP to actually upload our data into the Google storage bucket so that we can view the results once the tests have executed. Okay, moving on. So we looked at how we set up the Selenium grid, how we built a test container image, and we publishing the test results. Now, how do we deploy the container image? Now, since this is only a functionality test, and we are not actually running an ongoing test container, what we initially started is that we built it as a job file, and we specified that the entire test is run as a job. We specified where is our Selenium grid as part of our setup, and the image that was built. We specify which bucket I want to store my test results, and all those configurations are specified, and we deploy our test containers into a Kubernetes infrastructure and run our test as like a batch job. So as part of this exercise, or when we did these testing, there were a few discoveries that we had, and we were looking at what we can be done. So a couple of discoveries we had is that the rules for setting up a Selenium in the Kubernetes infrastructure was really complex. There were a lot of permissions that we had to give in terms of service accounts of how to, so that it can actually instantiate and scale in a fashion that we want. There were some challenges with the Selenium infrastructure, especially because they do a lot of video recording. So we found that though it is scalable as an infrastructure, but at times there were some issues in terms of when it did a lot of recordings, it was very unstable. And we always had to sometimes reinstall or restart our Selenium pods to basically make it working. Not as frequent as we used to do for test infrastructures, but it was still not very stable. So one thing we noticed is that once we ran the test with in the Kubernetes, we didn't have a mechanism of actually sending us a notification that, okay, the job is complete and that your test results are ready and available for your viewing. Now, this kind of when I published this article about executing end-to-end tests in Kubernetes, we were all in a phase of learning and evolving of how we can use Kubernetes for our testing purposes and how we can make our test infrastructure more scalable. But after doing and working with this process, we actually evolved and said that, okay, how can I see my view test results? It's so difficult to view the test results. So we made some improvements, and the best way we thought of executing these tests is executing these tests in a scalable Jenkins infrastructure, where in the Jenkins slave environment, Jenkins actually has the Kubernetes setup. All you do is that you specify your entire job as a slave pod, and you run the test in that Selenium slave pod. So we did exactly the same setup that we had to execute the test containers, but instead of running the test containers as Kubernetes job, we ran them in our build infrastructures as a master and slave configuration. So I'd love to hear if you have any questions and specifics that I want to dive into. If you have any questions of how we achieved it, or any questions around what other challenges we had, I would love to hear teams have.
Yeah, and folks, if you have any questions, please put them as a comments on YouTube link, and I would delegate over to Deepa.
Is there any question on YouTube? If none, then I think Deepa can continue.
Right, yeah, please continue. I don't think so.
Yeah, I did had planned for a demo, but which we are not covering here. So actually, I'm actually at the end of my slides. So all I want to say is that please do feel free to try our application, which we basically are into incident management. We help to engage a lot of application in terms of if you have any DevOps processes that are not automated, you can definitely check out our XMatters application to basically automate those processes so that you can get the right people engaged to actually solve your problems rather than doing all the paperwork when things are burning or down. So that's it. Thank you for your time and for listening through my experience. And if you have any questions, please do shoot out me an email. Damien, I will share the email address and teams can reach out to me if anybody has any questions. Thank you.
All right. Thank you, Deepa.
Yeah. Thanks, Deepa. That was really nice. And do you think your presentation we can put up on the meetup page?
Yeah, that's totally fine.
Public, okay. Okay, good. And since you're going to hang out for Damien's session, if there are any questions, I'll just put them here.
So give me just a second to bring my pad, and then I'm going to start the presentation, okay? Just 1 second.
So Deepa, this XMatters, your company, do you guys have the trial version available?
Yes, they are. Yeah. Yes, we do. You can try it out. It's XMatters free. That was there in the presentation. The link is present over there. Yeah.
Okay. I'm personally very interested in chaos engineering too. And you mentioned a little bit about chaos engineering. You guys have built your own tool.
Yeah.
So that's something I would be interested in checking out personally.
Yes, it is. Yeah, it is We built it initially only for the Google Cloud Platform, but I think the community has contributed towards running those tests even on AWS. Yeah, yeah.
Okay.
And yeah, it is pretty nice because typically with Chaos Monkey and all that, they only cater to certain applications, whereas this one, it is more like you can define as a scenario and say that I want to randomly shut down this pod and I want to repeatedly shut down this pod, so that you want to simulate a scenario where you want to repeatedly recycle your microservices. You can totally do that. Yeah.
That's pretty nice.
Yeah, I would highly recommend checking that out. This is the first tool that we open sourced, and we're really proud of it.
Okay, and what's the name again?
It's Cutulu. Cutulu.
Cthulhu. Okay.
Okay. Yeah.
All
Good.
right. Thanks, Deepa.
Yep.
So,
You're welcome.
yeah, you guys can see my screen, right?
Yes, Damien. It's a
yeah, just plain.
yeah, plain.
For now, it's plain.
Okay.
All right. So I already introduced myself at the beginning. However, you know, just to know a little bit more about me. Basically, I'm a certified Kubernetes administrator. So mostly what I do is around training and consulting. So all around Kubernetes administration. And I love running. And I try to do one marathon every year. I'm not sure about this year because of the pandemic, but we'll see how that goes. So that is about me. So the presentation I'm going to give, I have been writing a series of blogs, and I will show you the links to those blogs, because what I'm going to present is just going to be one of them. And really, I got a lot to share. So I think we can basically, we will be able to use up the rest of the time, even if it's just asking questions. So let me show you the series of blogs that I'm writing, so that if you want to go and have a look at them later on, you can do that. Because as a matter of fact, what I'm going to be talking about is going to require that you have some knowledge, but I'll try as much as possible, you know, to take you through the fundamentals so that none of you is lost.
Sure. Damien, so just a quick thing.
Yeah.
So Deepa, there is a question for you. And in fact, I was wondering myself, I tried quick Google search to for that chaos tool that you guys have built. So we have a question on YouTube asking for the same thing, that how do you spell that name?
Oh, it's CTH. Should I send a link, or is that
Yes,
a way?
Yeah, that'll be much better.
Okay.
Thanks. Sorry, Damien. Over to you.
No problem. Okay, so I had those links earlier. So I'm going to try and bring up another link just to show you those, and then we'll get started. So it's on my other screen. Let me bring this over here. Let me bring it over. Okay, so cloud. Actually, that should be on another screen. So this one. Okay, perfect. So here are the series of blogs. I will send those to you so you can have a look. So basically, it's all around microservices. If you are new to microservices, if you want to learn more about what they are, because what Deepa presented is all based on microservices, but you may want to have a fundamental knowledge of what microservices are. So this is what this series of blogs are meant to do. So this is the fifth one. Actually, this is their like fifth series now. This is number 1. And if you keep scrolling, you come to the one that I'm going to be talking about today. So here's one of them, and I'm going to scroll to the one that I'll be presenting today. So this one here, let's go to this one here. Accessing microservices with Kubernetes Objects. All that is explained there, and then this is the one I want to talk about. The reason I wanted to talk about this was just based on what Deepa was presenting. Okay, but I'll try to summarize the main points in the previous one so that, like I said earlier, nobody would be lost in the presentation. Okay, so basically, it's going to be about how to do some basic CI/CD on Kubernetes without using any external tool. This may not be for every scenario or every use case. It's going to depend, of course, but at least you know how to do the basic stuff in Kubernetes when it comes to CI/CD. All right. So the architecture of the microservice I'll be talking about is here. I'm not the one who wrote the application. I'm just using it as an illustration for what a microservice application looks like. So let me show you the architecture. And then after that, we can continue the presentation. I actually have it on one of these here. Maybe the first one. Right, so here's the architecture for the microservice we're going to be talking about. I don't know if it's appearing good. So basically, these days, microservices application architectures are becoming the norm. They are becoming the de facto standard just because people are moving the applications from on-premise to the cloud. And as you move your applications from on-premise to the cloud, there's a need for you to re-engineer those applications from monolith to microservices. So as Deepa said earlier, almost everyone is doing that. And that is why this area is big at the moment. And because Kubernetes is about the de facto API that enables you to perform these operations, you also see why Kubernetes makes a lot of sense these days. So in my presentations, it's all going to be hands-on. I will show you how this thing works, and we'll use as much time as we have, like I said earlier. And feel free to ask questions. If you shoot your questions to the meetup page, Himansu will let me know, and then we can try to answer them. I'm going to go very basic, just like the fundamentals, and I'll build it up, okay? Because I do realize, having running this meetup for some time, I do realize that a lot of new people comes in, and most of the new people may not have much knowledge, okay? Some do have, but not a lot, most of them don't. So in order not to lose everyone, that is why I want to take it gradually. So for those of you who are already knowledgeable in Kubernetes, it could be boring, but for those of you who are new, it will help you to bring you up to speed, okay? So starting with microservices, seeing how Kubernetes helps you to deploy this application, these are the kind of stuff I'm going to be talking about, all right? So we see the diagram of a microservice here. Basically, this one is called the voting app. And like I said, I did not write it. So you can actually clone the repository from here. And I have it cloned already. So I'm going to basically show you how to do CI/CD, basic CI/CD with this voting app application, which is publicly available for everyone. And this, as you can see here, this microservices has five components, 5 microservice services. So there's 1, 2, 3, 4, 5. So a microservice, let me try to write a little bit just to explain it, what we are talking about here. Don't permit my writing. I'm not very good in drawing. But basically, if this is your monolith, that is your monolith application. Okay. Then you want to chunk it up into several components. And this is what we basically call a microservice. So A, B, C, and D. So here we assume you have 4 microservices, okay? A, B, and D. In our microservices architecture, we're going to have them as loosely coupled applications. So here becomes our A, B, C, and D. All right, so simple. We break the monolith into the microservice. Now, how you do that, in essence, is called decomposing the monolith. That is a whole lot of topic on its own. Depending on how knowledgeable you are, it may not be that straightforward or easy, or let me say it might be challenging for the developers to take this into this. But that is what a microservice looks like. And so as you have this microservice, in terms of deployment, and this is where Kubernetes comes in, you normally want to deploy each one of these to a Docker container or a container. It doesn't have to be Docker. So you're going to have a Docker, a Docker, a Docker, and another Docker, all right? Containers. Before you do that, of course, if you're familiar with how Docker works, you first have to make sure you create the image. So you have to first make sure that you create the image of your microservice. Then from your image of a microservice, you can now run a Docker container. So now you have 4 Docker containers. Usually, it's a microservice to 1 Docker container. So 4 microservices, 4 Docker containers, or 4 Docker images. That is if you are doing that at the Docker level. But you often want to do this with something which is capable of handling all the challenges of this microservice application, because essentially, this microservice application is a distributed system. It is a distributed system. And if you've worked with distributed systems before, you know they are challenging. And apparently, my PhD was actually on distributed systems, so I can relate with all the challenges here very well. So now you have these distributed systems, you have to take care of certain things. You have to take care of things like communication. How does one microservice communicate with another one? For example, this may need to talk to this, or this may need to talk to this, as the case might be. How do you handle all that? How do you handle scheduling? How do you handle scheduling? That is, how do you decide where this container is going to run? Because pretty soon I will introduce you to the Kubernetes architecture, where you're going to have a bunch of nodes, a bunch of cluster nodes. So the problem of scheduling is, how do you decide where this should reside? Do you want to send it here, or here, or here? So scheduling has to be taken care of. And then you also have to make sure you take care of things like logging. All right, I'm just going to mention a few of them, and then I'll move on for the short time that we have. So things like logging, things like monitoring, things like how do you handle your security, how do you handle your tracing? That is, if you are moving from one microservice to another, how do you handle the tracing? How do you handle your load balancing, LB, on and on. So there are a lot of problems that you need to handle. But I mention all this because this is where you need something to come and help you. And this is where Kubernetes comes in. Kubernetes comes in as your cluster manager, your orchestrator, who says, all right, you developer, you DevOps, don't worry so much about how to manage all these complexities of this microservice application. I'm just going to help you manage it, and to you, it will look like it's very easy. And that is the whole aim of Kubernetes. From the user perspective, it simplifies a bunch of things that makes things so easy that without Kubernetes, it's almost going to be impossible to handle a microservice application. All right, so as we know, Kubernetes is the de facto API for handling your microservices, because it's very good in coordinating all these activities that I mentioned here. All right, so this is where Kubernetes comes in. So I was talking about the cluster earlier. So let me show you a diagram which would be better to explain how the Kubernetes architecture looks like, and that is what I have here. All right, here we have the control plane and we have the data plane. On the control plane, we have something called the Kube Controller Manager, the Kube Controller, the Cloud Controller Manager. We have the Kube API server, we have the Kube Scheduler, we have the etcd server. Basically, when you have a Kubernetes environment, let's assume that you have 4 computers. They can be virtual machines, right? It doesn't matter. They can be virtual machines. But let's assume that you have 4 virtual machines. There could be physical blades of virtual machines, 4 of them. So you have to designate one or 2 of them to be your control plane. Let me make this slightly bigger. It's easier to write when it's bigger. So you can decide to make one of these to be your control plane. And then these 3 can be your data plane. Basically, this would be your node 1, node 2, and node 3. So that is what I was trying to show you over there. Now, when you have your control plane, or what you call your master node, you have certain services to install here. And that is what the architecture was saying. You have to install your API here, called the Kube API server. You need to install your scheduler, okay? The scheduler that takes care of this problem I was trying to talk about. The one that decides where to send your microservices application. Should you decide to put it here or here or here, all right? And then you have your controller as well. In the last meetup, I explained that your controller is pretty much an object which goes into monitoring your certain objects to decide, to make sure that your desired state is what is your desired and your current are the same. So you have your desired state, the system will make sure that what you want is actually what the system presents to you. So it's continuously monitoring your objects, certain objects, okay, like replica set and deployment objects and the rest of them. And we're going to come across them later on. So basically you have your control plane, and then on each of the worker nodes, you need to install your kubelet, and I can show you those so that we don't have to waste time on that. So if I go back to the slides, so here you need to install your kubelet, your kube proxy, and then Docker has to be on every node. Docker is not shown here, but you need to have Docker on every node because that is the runtime that will actually coordinate your microservice in running those containers that you have running. All right. So this is what the architecture looks like. I'm not going to go too much into it so that we can go to what I wanted to talk about. So your etcd is your key value store. See this to be like your database, your MySQL database, or whatever you want to call it. So all the information that the control plane is creating, they get stored right here on your database, your etcd server. Now, there is one component which is not mentioned here, which we are going to use a lot, is simply called a kubelet. The kubectl, not kubelet, kubectl. Kubectl is the tool, the CLI tool that I'm going to be using to manage this environment. Okay, kubectl, KUBCTL. Okay, that's a client tool that we use for managing Kubernetes. The one we use for talking to the API server. Everything you are doing, you have to talk with the API server. And to talk to the API server, of course, you need to go through authentication, authorization, and all that. Okay, so you can see that Kubernetes is actually very big. There's a whole lot to it. But this, this is kind of bringing you up to speed so that I can do what I want to talk about. So kubectl will help you to talk to your cluster. The beauty of Kubernetes, the way I see it, especially one thing I love the most is that it doesn't matter how large your cluster is. It doesn't matter if you have a one node cluster, which you can, like all in one node, or you have a 5,000 node cluster. It doesn't matter. All you are going to do is you're going to use your kubectl command to talk to the API on the controller node, and you don't have the notion that you're actually dealing with a very large environment. All right. So that is the architecture. Hopefully now you understand, so that when I go to my environment, because now I have my cluster deployed where I'm going to deploy the microservice for you. I already log onto the server. You can see that it's saying master one. Let me see if I can make it bigger so that I don't strain your eyes. So hopefully that is better. So, okay, let me clear the screen. All right, so hopefully this is better. So I already cloned the microservice application. The Kubernetes components are all residing here, all right? So let's see what our cluster comprises of. Kubectl gate nodes. I want to see how many nodes this cluster has. So it's telling me that I have a 5-node cluster, though one of the nodes is not ready, but the other ones are sufficient for me to do what I want to do. So here I have a 5-node cluster, 1 master node, 4 worker nodes. 1 is not ready, so I have 3 left to use for my demonstrations. So like I told you, everything we're going to be using for this lab demo is going to be kubectl. That is the command we're going to use in talking to the Kubernetes API. So kubectl has a bunch of commands, and again, that would be another big area to go into. But all of that, you can go through those blocks I told you about, and they should put you pretty much on the right track. And then you can supplement that knowledge with something else. So that is what we have there. Kubernetes is also organized into what we call namespaces. Namespaces are more like how you isolate your different environments. So here there are a bunch of namespaces. However, when I create the application that I'm going to be dealing with, is going to use the vote namespace. So you see that all commands I'm going to be issuing, I'll do something like kubectl get pulse -n vote. Basically, I'm saying, show me all the resources in my vote namespace. Now there is nothing in there because I haven't created the microservice application yet. But very soon I'll create the microservice application, and then you start to see the objects that are under this namespace. So if I just to show you, if I do kubectl get pods minus n kube system, you see that there are a bunch of pods running right here. Okay, you have a bunch of containers running already on this environment. But in my own environment, like I said, nothing is there yet, so you don't see anything. Okay, so let me clear the screen so we can come up here again. So basically, that is the architecture. That is the tool I'll be using. The microservice application is already cloned to this repository. And so let's just create the microservice application. And basically, I'll create them, then I'll explain something before I move on. So if I could say kubectl create -f, now when I say create, I say -f, I'm going to give it the files that is going to use the YAML files that the microservice is using. So I'll create them, then I'll explain what I'm talking about. I put a dot, which means create all the YAML files in this namespace, or in this directory rather. Create all the YAML files in this directory. So now I can say kubectl get pods -n vote. And now it's showing us the resources that I just created. So some of them are still creating, all right? And then, all right, so now I have all of them up and running, kubectl get pods -n. So I have my microservices running. You can see that I say this microservice has 5 microservices, okay? So that is the number 1 microservice, second, 2, 3, 4, 5. 1, 2, 3, 4, 5, okay. So now we are looking at pods. Let me explain the basic Kubernetes objects, and then we can move on from there before I come back to here. So the basic Kubernetes objects you come across are called pods, okay, replica sets, and then we have deployment object, and then we have service object. Okay, these are the ones I need. And if you come here, if you do kubectl API resources, kubectl API resources, basically these are all the Kubernetes objects. But you can see that there are a bunch of them. Everything from here down. You can see that the pod is this one here that I'm going to be talking about. So just a few that are important for these discussions. There are a bunch of them. You can always look at them later on. So a pod, for the sake of the presentation, to make it simple, can be a container, but could contain more than one container. So that's a pod. So if I say pod or I say container, I'm actually referring to the same thing. It's not a slip of tongue, but for me to be technically correct or politically correct, I need to say pod because we're in Kubernetes. If I'm Docker, I can say container, but now I need to say pod. Now, Kubernetes is used for scaling. That's one of the main things. Kubernetes is good for scaling your microservices. It's good for managing your microservices. Okay? And it's good for deploying your microservices. So those 3 things are the main things that Kubernetes does. Manage, or at least deploy first, then manage it, then scale it. Those are the 3 main things. So replica set helps you to scale. Okay, helps you to scale your microservices, or you can call it your pods. And then your deployment objects, these are higher abstractions on top of the replica set. Replica set is this one here, replica set. These are the higher abstractions on top of replica set objects. So basically, they can scale as well, but they will do more things, And this is what I'm going to be using for the presentation. Actually, this is very important for the presentation because I'm going to be using a lot of stuff. I'm going to do all the demo using the deployment object. And then the service object, in a simple terms, this is your load balancer. So load balancer, because when you scale your containers, when you scale your pods, okay, let's go back here. Let me create another screen. So when you scale your pod initially, maybe it's just one. But remember, Kubernetes is good for scaling. By the time you scale, you can have like 5 replicas of your pod or your container. Now, when you have those 5 pods, all of them are running. Okay, let me just draw 5 of them quickly. Now, if a user is here and the user need to talk to any of these, you need to have something in front, the traditional way of designing architectures. So the user will connect to the load balancer, and then the load balancer will maybe use round robin or whatever algorithm it's going to use to select one of these round robin algorithm. Okay, if you're familiar with how load balancers work. So your service object is basically your load balancer. Now, as far as microservices are concerned, and this is very important for you to take note of, as far as microservices are concerned, you always, developers always use deployment objects and service object. Okay, they use deployment object to create the pods, okay, because you don't want to create pods by themselves. Again, if you go back to the first series of my blog, you're going to see all the explanation for that. The service object is very important because, as I explained here, once you scale these pods, you cannot access them except to use a service object. So as far as microservices are concerned, these 2 objects are what you need, at least at the very basic level. And those may be all you need, really. Maybe a little bit more, but those are always going to be present. So if I come back here to the screen that I had earlier, again, let me clear the screen, and let me try to make this, it smaller so that I don't have to always clear the screen. Oops. Let me try to make this. Okay, I'm clicking on the wrong thing. Don't save. Okay, all right, this is this one here. So I'm going to make it shorter so you can see all the screen. Okay, I think it's better this way. All right, so if I do ls, for the 5 microservices, you are going to see deployment objects. Let me do list -al. I'm going to see that we have 5 microservices, and so you have the database deployment and the database service. You have the Redis deployment and the Redis service. You have the result deployment, the result service. You have the vote deployment, the vote service, okay? These other ones are stuff I put in there, so I might as well delete them. But basically, you can see how that is architected. Now, these are all written in YAML. If you are familiar with YAML, then good luck. If you're not, again, I cannot explain what YAML is. It's just a way to present your data so that they become universal to any application that want to read them. JSON, YAML, these are the data serialization applications that you have in our modern architectures. So all this is written in YAML. If I open one of them for you, let's do the vote deployment. So basically, this is what you are presenting to Kubernetes in form of a deployment object. So that is a deployment object we're dealing with. Again, I can agree all this is not going to be very clear to most people, but you can always go back to the blog, all right? But the deployment object has certain attributes, and so everything from here to here is all about the deployment object. But from here down, we have a template for the pod that we like to manage. And right here, we have the image that we're going to use, the Docker image that we're going to use for this container. So you can see that for the pod, and everything from here down is about the pod. And this pod has this image that it's using. And I can go to Docker Hub and show you this image. And we might as well go there now because I'm going to need to do that in a short while anyway. So let me go to the web browser. Let me use this one. And if I create another tab here and I go to Hub, I'm going to go to Docker Hub, hub.docker.com. This is where all Docker images are stored, just in case you are not familiar with Docker and all this stuff. I can sign in, or I can just look for it there. It doesn't matter. Let me see if I can remember my username and password. If I don't, I'll go back there and can still show you. I can say not now. Oh yeah, I got the password right. So now this is the user that created those images. So if I search for Docker samples, I'm going to see a lot of images that this guy created, or at least that are created for this project. So basically, the image that we're using here is actually this one here. It's Docker samples, a sample voting app underscore vote. All right, that is actually this one here. Oops. Okay, this is visualizer. Let's go back. That's not the one I wanted to click on. All right, so this is the one, a sample voting app vote. This is the image that we're using over there. Okay, so I'll come back to this later. This image has different versions. They are called tags. If you click on the tag here, you see the different tags for this image, different versions for this image. Currently, it's using this image, this version here called after. And in my demo, I'm going to change that image to something else. So it's using after, but I'm going to change that to something else as we go along. So basically, here's a deployment object. For every microservice, you need to create this file, because this is the file that's going to help you manage this particular microservice. And not to explain every other thing, but hopefully what I just talked about is sufficient for you to understand what I'm going to be talking about in a short while. Okay, so basically that's a deployment object. And let's see the service object. Okay, let's do the vote service object. I told you this is your load balancer, and also all YAML files look similar. So here the kind is service, So in fact, if you want to create any other object in Kubernetes, it's all a matter of changing the object type kind here, and then every other thing here could change based on what you put here as a kind. So for this service object, this is what we have. But take note of something here. I'm going to use them. These are going to be pretty important for what I'm going to be doing. Labels. Labels are used to, they are like tags. It's like if you are doing any development work, you can put some tags on your development pods or containers, and you can put some tags on your production containers. For example, you can say tier equals web, or tier equals app, or tier equals database. These are labels. The labels are good because they help you to query based on those labels. And I'll show you in a moment, you can query based on the labels you give. But most importantly, service objects uses labels to find the endpoints. Okay, remember I said a load balancer, a service is a load balancer. So these are what we call the endpoints. Okay, that is important because I'll be using that a lot too. You can refer to this as the endpoints, which the pod. So which means this load balancer has 1, 2, 3, 4, 5. He has 5 endpoints. The load balancer is able to find the endpoints using labels. So if I label this and I say app equals tier, or app equals Nginx, okay? This has to make sense to you, but they are just labels. Then in this load balancer, I can say service object, please go and fetch for me everything that has this label. All right. So it's just a label, but it's very powerful. Without them, your service objects will not work. And that is what I'm going to be using to demo the features that I'm going to be showing you. So basically, here we gave it a label. This label is for the service object itself. But when we come down here, we have something called a selector. Selector, we're saying, go and look for any pod that has the label app equals vote, which is what I just explained over here. So every service object basically must have labels and label selectors. So you put the labels on the pod so that you can select those pods from your service object. Okay, I hope that is clear. Otherwise, as I keep going on, you see what I actually mean. This is fundamental to understanding what I'll be doing today. All right, so that's your service object, and that is the other one I showed you was a deployment. And like I said, you have them for each of the microservices that we have. So if you look at them, they are all going to look similar. The major difference in all of them, especially the deployment object, will be the different images, the different Docker images that they're using, okay? So now we understood at least a little bit of YAML files and how we use them in Kubernetes. Everything you do with any of those objects I showed you earlier, you are going to be using YAML files. It doesn't matter if you're managing this from a dashboard or from your CLI, you still need the YAML files. So, and you don't have to be scared of them. If you don't know how to create YAML files, you can always download them from the Kubernetes website, okay? And that is actually what you spend a lot of your time learning when you're trying to learn Kubernetes. Is about creating those objects, because everything in Kubernetes is an object, all right? So basically, I hope now you understand the basic Kubernetes objects, the pod, the replica set, the deployment object, the service object, which I put here, and then the labels and the label selectors. So those are going to be important for our discussions tonight. I also mentioned endpoint, okay? So I think with that, we're good to go. So what I'm going to do, I'm going to show you what I'm going to do. So basically, I'm talking about how you can do CI/CD with Kubernetes objects. All right, Kubernetes objects. And basically, what is CI/CD? Now, this is a large topic, but basically, it means that, well, usually how it's done is that for the architecture I was showing you earlier, let me see if I can find it quickly. So one of the things that microservices aim to achieve is that for these 5 microservices, so you're going to have a team managing each one of these. A team will be managing this, a team will be managing this, on and on. And because these applications are meant to be completely independent of each other, this team can check out their own code to GitHub, all right? They can have a separate repository for this one, separate repository for this one, and teams are working independently of each other. So CI/CD, continuous integration and continuous deployment, is ability that a feature or a practice that will enable these developers to continuously make changes to their code. So as they're writing the code, they should be able to continuously push those changes to the production environment if they so wish. If they so wish to do that. They don't have to push it all the way to production, but if they do, if they want to do that, then they can easily do that. And the whole idea here is all around DevOps, right? You want to fail fast. You want to fail fast so that if something happens, you don't want to wait until the end of the program where you spend like months developing an application, as they used to do back in the days with waterfall. They spend months and years developing an application and before they start to test. No, these days, you want to do agile software development where you are pushing your changes every second, almost every second, or as frequently as you want to do. Maybe every 12 hours, you know, the team will decide. But Google, if you guys don't know this, Google deploys, they say they deploy 1 billion containers every single day. So that is the DevOps practice that a lot of people do. So basically what I'm going to show you here is how you can use Kubernetes to continuously push your code and then make those available in the production environment. And basically what I'm going to show you, there are going to be 3 strategies that I'm going to talk about. One is called the rolling update. And then we have what we call the blue-green, which is very famous, blue-green deployment. And then we have what we call the canary deployments. So we have canary. Rolling updates, blue-green, and rolling canary deployments. Now I cannot get I'm not able to get feedback from users. Otherwise, I would have loved to be asking you questions to see how many of you are familiar with this concept. But in any case, I'm going to show you how to do this basic stuff. And then if you have some questions later on, you can ask those questions. So rolling update is basically a way for you to update your application when it's live. All right. So all these strategies, they are going to help you update your application while it's live without losing touch with your customers. So your customers can be online, but you are still being able to push those updates that developers are making. In this case here, since everything resides in an image, so basically we're going to say we have an image 1, which is what you are currently running in production. Let's say this is currently in production. And then you have image 2, which is the new image, This one is where the developers have just made some changes. And you want to be able to roll this out to this without losing your customers. Okay, now everything is going to concentrate around the deployment object. You see the Kubernetes deployment object that I told you about, and I told you that developers will always use deployment objects for deploying their microservices. So I'm going to be talking about how you can use deployment objects to achieve these methodologies. All right. So with the rolling update, you are basically going to be working with one deployment. You're going to create one deployment object. It's managing your microservices. Everything is running. Everything is perfect. Life is good. Then, boom, you are going to upload this new image to your production environment, and then you see how that works. That is what I'm going to show you. Blue-green is a terminology that people like. You can use. Some people use blue. Is it red, black? Some people use red, black. Depends on. Those are the two most common terminologies, but it's just a matter of, it's just a way to illustrate that you have two different things. One is online, the other one is offline. So blue, in this case, we can say blue equals online, and we can say green equals offline, which is kind of like the same as I talked about here, image 1, image 2. The only thing is that here, we are working with one deployment object. And of course, I'll show you what I mean in real life. So the blue-green, you're going to have two deployments. Okay. Deployment objects. So one is going to be called the blue, which is going to be the one running your version 1 of your image. And then the offline is also going to be running the version 2 of your image. So as you keep making those updates, all of a sudden, if this becomes online, you can switch customers around. You can switch this to deployment around. All of a sudden, you can make this one to be online, and you can make this one to be offline. Okay. So from what I just talked about so far, we can see that these tend to be a lot more reliable. People tend to prefer this one because here you're actually working on your production environment. And if everything goes wrong, then you can roll back. If things don't go well, you can roll back. But otherwise, this is a little bit tricky. But this one here, you are not touching the online. You are just switching to something which is already tested to be working fine. So if one doesn't go good for any reason, I don't know why it wouldn't go good, because you've already been spending all your time testing before you're ready to push it online. But if anything goes wrong for any reason, maybe just switch back to your blue. Okay. So different way of doing things. As you can see, this one could be a little bit pricey more than this, because this is just one deployment. This is two deployment objects. If you are running 4 pods here, you're probably going to be running 8 pods, or maybe 6, because you don't have to make the offline one to be equal to what is in production. But you get what I mean. This is going to be, has a tendency to be more expensive, but more reliable. Canary is basically almost the same as blue-green. But the difference in here, the difference between blue-green and canary is that here, they're going to also have two deployment objects, but both are going to be online, both online at the same time. Here, only one is online, the other one is offline. Here, both are going to be online at the same time when you are doing the test, when you are doing the continuous integration and continuous deployment. Both will be online until you are ready to switch to one of them. When you feel that your production environment or your environment is now what you want it to be, then you can switch to just one of them. And that is the one that your customers will be using at that point in time. But while you're doing your CI/CD testing, both will be online. If both are online, then you have to split your traffic. You have to split the traffic among the two deployment objects, among the two deployments. And basically, people can use things like 70 to 30%, where the production is taking 70% of the traffic, and the the canary, the new one you are testing, can take 30% of your traffic, until when you feel that one of them is stable, then you can either bring the canary to 100% and delete the old one, or you can delete the new one and upgrade the second one, okay, depending on how you want to do it. But the idea here is that both of them are online. Now, why would you want to do that? Why would you want to put both of them online? Well, this is depending on the scenario, but this is very good for testing. It might be that some of your customers are asking for all these new features and you want them to test these features before you actually roll it out to all your customers. That is one of the reasons why you may want to do that. But any of these strategies, you can use them together. You can combine them. You can use maybe just these two. You can stick to one of them. Most DevOps teams will, choose which one they feel they are more knowledgeable about, or which one will help them more. So hopefully that explanation makes sense. I'm going to show you each of these, how to do rolling update with Kubernetes objects, how to do blue-green, and how to do canary deployment. Bear in mind that you could use more sophisticated applications outside there to do this stuff. You can use things like Jenkins to set up your complete pipeline, but I'm just going to show you the basic way to do it here that could keep your environment up and running. And when it comes to canary, Kubernetes is not actually very good with canary. This one's no problem, it's perfect, but it's splitting the traffic into like 70, 30 that I talked about earlier, ratio of maybe 30 to 70, that is difficult to achieve. And most people will use something like Istio to do this. If you've heard of Istio service mesh, the world of Kubernetes is very big. People will normally use Istio service mesh to implement a very good canary, because Istio has a capability to ask you how much traffic you actually want to split, and Istio will go ahead and do that exactly as you want it to be. But here, I'm just going to show you how the strategy works in Kubernetes. And all this is kind of, if this is first time you hear about this stuff, to go and research them more. If this is something your team is using, to go and learn about them more. I always tell people this, Kubernetes is going to be like Linux. I mean, right now, if you're looking for a job and you have some Linux knowledge, I think you stand a good advantage over someone who doesn't have any Linux knowledge. That is where IT has come to, as far as I'm concerned. In the future, it's going to be the same. No matter the job you're looking for, especially any DevOps role, a knowledge of Kubernetes is going to be required, because it is simply the operating system of the cloud. So you cannot avoid it. You see that you're not using it on your job now, and you start learning it to prepare yourself, or you're already using it, and then you have to continue to learn it. But anyhow, I think Kubernetes is very important in our current IT infrastructures. So most of this is just to whet your appetite, to whet your knowledge, so you can go ahead and do more of that. Perfect. So now it's going to be demo time. I already have my setup, Cutulu get pods. All of them are running. Oop, I need to put my namespace. -n vote. Everything has to be on that vote namespace. I have my microservices running. I can show you my deployment objects that brought all these objects on. Kubernetes Cutulu Gate deployment. I got all my deployments, so you can see that each one of these deployments is managing those pods. Okay, just to show you an example, your deployment is a controller object. So if I delete any of this one, this guy is going to bring it back. Okay, so let me just delete one of this. I'm going to delete that pod. Cutulu delete pod minus delete pod that -n vote. Okay, it's deleted, but before it gives me the screen, you see that that pod will be replaced. Okay, Cutulu get pods. So you see, the one I deleted was the vote, and now I got a new vote, which has been running for just 12 seconds. So basically, all those pods are controlled by the deployment object, and that is the reason why I was telling you that you don't want to create your pods directly, because if you create them directly, we call them orphan pods. Orphan, they don't have any parents, so no one is monitoring them, no one is looking after them. So by putting them under a deployment object goes ahead and keep monitoring them. And now you can scale as well. Let me just show you how to scale. I can say Cutulu scale deployment vote. minus replicas equals 5 minus n of replicas. Okay, it's scale. So Cutulu get pods minus n vote. Now I got my scale. Remember, Kubernetes is used for deployment, scaling, and managing your microservice. So you see how easy it is for me to scale. Now I'm going to scale it back to 1 because I don't want it to be at 5 for what I want to do, so that I can easily show you what it's doing. And now if I say that, now it's terminating all the extra ones that are not needed because I want 1. This is what we mean by your desired state and your current state. Current state says 5. Desired says 1. All right, what does Kubernetes do? Reconcile, bring it to your wish. So let's run that command again, and now we're back to where we were. So this is just showing you that the deployment object is managing all those pod objects that are running. And then let's check our service object, kubectl get svc minus n vote. Now, when I check my service objects, I see that I have a service object for database, for Redis, for result, and for vote. Okay. Now, if I do kubectl get endpoint minus n vote, it's showing me that all my deployments, all my service objects has one endpoint. This endpoint, you can guess, these are your pods. These are your pods. How do I know? If you say kubectl get pods minus o wide minus n vote, it's showing you the IP addresses. So you can see that this one 8.10.47.08 is this pod, the database pod. The Redis, let's check the vote. The vote is 10.4.40.14, 10.4.40.14. That is pretty much this one here. So like I said, I'll be using this a lot. I'll be using the service object, I'll be using the endpoint, and I'll be using the deployment. So these are the things you need to know. So basically, these are your endpoint for your service object. In other words, when traffic comes to DB service says, okay, forward it to this pod. And you can have a lot of these. In that case, the database service, which is a load balancer, will be doing round robin to forward it to the respective endpoints that you have configured. All right, perfect. So let's test this application first of all. Now, there are different types of service objects. For the service objects that we have here, this is called a node port. It's telling you a type is a node port. This one, it says it's a cluster IP. Cluster IP are local. Node ports are kind of more you can access your node port from outside your cluster. Cluster IP means it's completely local. You cannot access it from outside. Node port means you can access from outside. So in this cluster, I should be able to access this microservice. So let me explain a little bit more about the microservice, then then we're going to access them. So basically, we have the result. As you can see, the name is called voting app. So we assume we're going to use this application for voting in the next coming election in November. Okay, so assuming this application is good enough, we're going to use it for voting. So people can basically vote at this endpoint, and then we can see our result at this endpoint. Now, this is a basic application, almost like a toy, but it illustrates microservices. So for me to access this application, I need that port. I need that port, and I need one of the IPs of my cluster. So I need to say kubectl get nodes minus o wide. Okay, so I need one of these IPs, and I need the port that I just copied. So let me go here, and then click on a tab, then put one of those IPs of the cluster, which is 192.168.0. I can use 5. I think 5 should be active, and I put a port there. And yeah, that's our voting app. We're going to vote between Java and .NET. And the reason is because of the image I have. Sometimes it can be a vote between cats and dogs, all right? But, you know, in our case, if it's a national election, you know what those two are going to be. So you can vote for any of them. So now for the result, we want to say our result microservice, we also need a port of our microservice. So the result is here. So copy that, And I'm going to go to another browser, create another tab, 192. Let's finish, let it finish. 192.168.0.5, and I'm going to put the port, boom, and I get my result. Okay. Now, don't worry so much. I said it's a toy application. Here is showing Java versus .NET, and here is showing this. Okay, but illustrate what I want to talk about. So let's vote and see if it maybe gets reflected. Okay, if it doesn't get reflected, I don't take the blame. I'm just using this as a demo. I'm actually writing my own microservice that I'll be using for demos, but for now I'm just using what I got. So the whole idea here is that this microservice enables you to view or to vote and then to see your result. And this is how Kubernetes helps you to orchestrate that. We have 5 microservices, all of them running in pods. First, you have to create those images and send them to Docker Hub, and then create your YAML files, deployment YAML files, and deploy them. Then put your service objects in front of them, and then you can use your service objects to access those microservices. And that's what I've done. So super. Now I can show you the 3 strategies, and we can almost try to run up, you know. So for our rolling update, let's say kubectl get pods -n vote. Now these are the pods I have running. Now I'm going to work with just one of them. Let me just work with the vote. Okay, because remember, anything I can do to one microservice, I can do it to the others. I can scale them individually. I can do rolling update on each one of them individually, but I'm just going to show you on one of them, and I want to choose the vote. So before that, let's see the image that this guy is using. To see the image, you can say kubectl describe pod, and I'm going to copy that, and I'm going to tell it the namespace where that object is. And now it's telling me a lot of features of this my microservice. And it's telling me that the image it's using is this one. Example voting app underscore vote, and the version is after. This is the one I showed you earlier. Let's quickly go there. So it's using this after. Now I want to change it to before. This is the version called before. Okay, where's the version? There is a version here called before. That's it right there. So let's assume this is our production. This is new. Okay, you understand the terms. Even though after and before may not correspond here, but the whole idea is we want to change this to another image. Okay, so for rolling update, let's see if I can remember the command. You can do kubectl set image deployment. The name of the deployment is vote, and you can say I'll show you. Let me show you the name that we're going to use for this. So I think I have 2 screens here. Okay, so I can show you some of this stuff and then go there to do the other ones. Okay, so here we're going to look at the vote deployment. And under the vote deployment, the name of our container is actually vote. So that is what I'm going to use here. I'll say vote equals, I'm going to give you the image that I wanted to use. Vote equals, I'm going to copy this image, the whole of this image. Okay, and I'm going to paste it here. Then I'm going to change this to before. This is the new one. Okay, vote before, okay, -n vote. That's the namespace. So basically we say kubectl set image for the deployment called vote, and let's change the image that the container vote is using from what it was before to the new one. All right, so let's see if this works. Let's press enter. Okay, very good. Say deployment vote image updated. So let's do kubectl get pods -n vote to see what is happening. What happened was it decided to terminate the one that has the old image, and now it created a new one, which is just 9 seconds. All right, so let's describe this one to see if the new image is actually reflected. Again, kubectl describe pod. I will just copy this one here and say -n vote. Now we go to see, look at the image, and now the image has been changed to before. So you see that I did not have to shut down Kubernetes or shut down my application or anything. I simply just asked it, give me a new image, and now it did it. I did it just on one to show you how that is working, but I can go ahead and do and scale this. I can say Cutulu scale deployment vote minus replicas equals 5, and I can say minus n equals vote, which is my namespace. Okay, so I'm going to scale that. It's already scaled. Cutulu get pulse minus n vote. I have all my new containers are being created. My microservice is being scaled, and all of them are running, which is looking beautiful. All right, so now I'm going to perform a scaling, rolling update again, and I'm going to change that image back to the latest one. So if I don't put anything in front of it, basically this tells the system to give me the latest image. I want to do that, and then I will show you, okay, it's updated. So let's say Cutulu get port minus n vote quickly. So you see how it's terminating some ports and creating new ones. It's going to keep rolling. That's why it's called rolling. It's going to roll from old to new, old to new, old to new. And then when it's done, everything we're going to have is going to be all the new. So let's wait that to finish. It's still creating. All right, it's going to get rid of those ones. Okay, let's wait for it to get rid of them just because I want a clean environment. Otherwise, it's simply done. Okay, perfect. See, all of them are just within the last couple of seconds. So if you say Cutulu describe pod, describe, and let's give it one of these. Anyone should do. And let's not forget the namespace. Now let's see what image is using. Voila, it's using the latest image. Perfect. So that is what rolling update is all about. You can online keep updating your application, and the system takes care of that. Okay. And like I said earlier, if something happened, you can roll it back. Okay. You can roll it back. I think I have the commands here to show the rollback. So basically, to roll back, you can say, first of all, you want to check your versions of your deployment. So that's the rollout history. You see, we perform all the updates, all the rolling updates we're doing, the system kept record. We first changed from after to before, and then before to latest. So it keeps the version, the record of them. So now, if I had issues as I was doing that, I'm going to roll out to version 1. I want my environment to be like it was. So you say Cutulu rollout undo deployment to revision 1, which is going to be this one here, the original one. I can also start it to revision 2, but let's leave it at revision 1. So if I do that, boom, everything roll back. I do Cutulu get port minus n vote. It's doing the process all over again. So it's beautiful. This is how you can continue working with your Kubernetes, and developers can keep updating their applications with their development, new development after they finish their testing, and they can continue doing their CI/CD pipeline. Perfect. So if we could describe it again, then after that, we're going to move to blue-green. Cutulu describe pod. Let's copy one of these. And let's not forget the namespace. And there you go. We're back to our original, which was the after image that we used. All right, so that is rolling update. Now, I did all that with one deployment. In the case of blue-green, I'm going to leave the current existing one running, okay? I'm going to leave that one running, and I'm going to create another deployment called green. So for that, I created a folder here called green, and I copied the deployment here. And if I open this deployment, which I already made changes to, you see now I only change the levels. Now I say type equals green, type equals green. Okay. So the syntax of deployment objects, I don't know if you got it when I talked about this earlier. You are going to see a label here. but this is for the deployment object. Then from the template, you are also going to see where you have the information for the pods. So you're also going to have a label here. And then you're going to have a label selector here. Label selector is basically saying, select this deployment will select every pod that has a label called type green. Okay, type green. So basically, I'm going to run this deployment. So I'm going to say kubectl create -f, and this should get created. Label vote green. So kubectl get deploy -n vote. I got that. So okay, now let me. Well, the deployment is there, vote green, but I want to see the pods as well. So get pods -n vote. So now I have this vote here, which is running. Now let me do a search kubectl get pods -l. Okay, I'm going to select based on labels. If I want to select my pods based on label, I can say -l type equals green -n vote. So it's showing me only one pod matches that label. And if I were to match based on the previous, I'm not sure what it was, but I can easily check that. Kubectl, or I can show the labels actually. We can also do kubectl get pods -show labels -n vote. And that's showing you all the labels. So the vote has a label called app vote. So just like the other one, I can query based on app equals vote. App equals vote. And that is showing me all the pods and houses. So we have two deployment. If I want, I can also scale this deployment that I just created. But for what I want to do, it's sufficient to leave it as one. Okay, so let's see what the current service object has as a backend. Okay, let's say kubectl get pods -n, get endpoints. Get endpoints -n vote.
Demian,
okay.
We have one question. I know Deepa already commented on that, but I just wanted to let you know. So Ganesh says, nice presentation, one question. During the rolling update, when the request comes in, will the old image?
Okay, yeah, I get asked that a lot. So, so you see that there's a load balancer, right? The load balancer can decide to take that request to anyone, and it can decide to run. Basically, what the load balancer do, if you know how load balancers work, they listen to the heartbeat. Okay, they keep sending some traffic, some packet or some text to the backend endpoints. So whichever one is alive is the one that is the service object or the load balancer would normally route traffic to. So it could be the old, it could be the new. But remember, it's not a big deal. You are just making these new features. It's not like your customer is saying, all right, I want those new features right now. No, at least the customer can wait because they've been working with the old ones all along. So yeah, it doesn't matter. The service object can route to any of them, whichever one is available at that point in time. Yeah, I hope that answers your question. So if we go back here and I say kubectl get endpoints, I see that my current endpoint for vote is having 5 replicas. It said 1, 2, 3 plus 2, which is 5. And basically, it's matching to all the ones that we scaled earlier. Okay. In fact, if I scale that down, you see that it's now going to match just 1. So let me just do that quickly because that'll be cool. Kubectl scale deploy vote minus replicas equals 1 -n vote. Okay, so now if we say kubectl get endpoint, let's wait for them to terminate first. So you have just one endpoint. It's perfect. All right. So if you take note of that IP address, we can go up later on to look at it. It's all having that. All right. So now we have two deployment. One is the original one. The new one is the one called green. So I'm just going to do blue-green. With blue-green, I'm just going to do kubectl edit service. I'm going to edit my service object, service vote. The name of the service is called vote, and the namespace is also vote. So this is going to help me bring up the YAML file for that service object. this is the view of the system. So I'm just going to basically look for, I know that label started with vote. I'm not going to bother about this one because remember, this is for the service itself. If normally in most deployment YAML files, you see that they're trying to have a uniform labels for all of them, but this doesn't matter. So I'm just going to get to the one that matters. Okay. So here I'm going to change this one to, I think was type green. Type green. I'm going to change that to type green. That's the label we put on the new one. All right. And I'm just going to save it. Okay, let's see. So that's a selector. Yeah, that's a selector. It's going to select everything that has green. Okay, that should do it. So let me do, I'm just going to save it. And as you save it, it said it's edited. If I made some typo, this will not, it will not exit. It's going to keep remaining there until I fix the error. So if it comes out smoothly, it means everything is fine. So basically, if I run this command again, kubectl endpoints, okay, if I run that command again, oops. See that the endpoint has changed. The endpoint has just changed from old to new. So now customers will get redirected to the green because that is what is online. That is what our service is pointing to. So before this was online, now this has become offline. So you see how easy it is to do this one. Once you create your parallel deployment, edit your service object, point it to a new label, and boom, everything is working as expected. And I just make it one so that it's easy for you to see. Even if I scale it, you see that everything will now match the new one. So let me just do that quickly before I go to Canary. So I can now say kubectl scale deploy green. I think that was the name. I'm not sure. Let's check it quickly. Kubectl, yeah, no, vote green. Vote green. Yeah, correct, vote green. So let's scale the replica to 5. And now if you check the endpoint, all of them should get populated. All right, you see all of them have gotten populated there. Perfect, everything is working as expected. So let's go to Canary. Like I said, with the Canary, you have still 2 deployment, but you're going to split your traffic into a certain percentage, right? So at the moment, I have this one here is 5. The vote is 5. So basically, I'm going to use both the old and the new. Okay, my service object now is going to be pointing to the old and the new. Okay, at the moment, it's only pointing to this. Now, if I wanted to also point to the other one, I just have to go there and change the deployment object. Okay, just change the label. So if you get what I mean, now I'm going to go give it the same label that this one has. The old is going to have the same label as the new. Okay, so that now my service object will be pointed to both of them. But I can control the split by making sure that my first deployment is maybe just 2 pods, while this one has 5, all right? So let me show you what I mean. So now I'm going to go and edit. I'm going to leave this one here, and I'm going to go vim vote deploy. So I'm going to simply give it a new label, and the label was type green. I'm going to give it type green. You get what I mean earlier, that the labels are very powerful in Kubernetes. So I'm going to give that label green, and then I'm going to also change this one to label green. So type green. Again, this one doesn't matter, even if I don't change it, but because this is for the deployment and this is the one I need. Okay, so let me save it. Let me save it, and then let me say kubectl. I'm going to delete the previous one. Delete -f vote deployment, and then I'm going to create a new one. Create -f deployment. Okay, so now kubectl get endpoints, get endpoint -n vote. Oops, get endpoint. So you see now we have 6. You say 1, 2, 3 plus 3 more. So now I have 6 because it's 5 from blue and 1 from green. Okay. Now ideally, you see how we do this? Ideally, the image of both of them should be different. Okay. One should be using the old image, the other one should be using the new image. And now I have them in percentage of 5 to 1. Okay, you can calculate what split is that. If I wanted to decrease or increase the percentages, I can manually do the calculation and decide if I want to leave the first deployment as 5 objects or 6 objects and then scale the other one to 2. So you control how that is done. And that is where I was saying that Kubernetes is not very good in helping you to do the calculation. But something like Istio, you can tell it, hey, I want 30% of the old and I want 70 of the new. That's all you have to tell it. I need to do the calculation and do it for you. And that is handy because now I'm only using few replicas. But in a production environment where you have so many replicas, you need a system that can help you scale it like that. So you can see the magic. The service object is now pointing to both the green and the blue, and both of them are active at the same time. And when you send your request, some of them will get directed to the new, and the other ones will get directed to the old. And now it's up to you to see how you can do the testing of the features. Like how do you call it? A/B testing. It's like you want to see what features this A is presenting or blue is presenting, and which features the green is presenting, all at the same time. All right, so it's a subtle difference between the blue, green, and the canary, and that is what people use. So now that we have both of them, once they are ready to say, all right, I want to now roll out the new. Let's say I want to roll out the new. All I have to do is kubectl delete deployment. I'm going to delete deployment, and I'll just say kubectl delete -f. The green, let me delete the green one in this case, green and the file. So now I'm going to delete that. And now I'm only left with one deployment object, kubectl get deploy, or let's say kubectl endpoints -n vote. So now I have just one, which is maybe the new one that I want. And all I have to do now is roll this one over, just scale it. Kubectl deploy vote -replicas equals 10 and -n vote. So basically, I have scaled the new one to any number that I want, and I've kind of basically just deprecate the other one. So once they are ready, you see all of them will get populated here, and that's all we got. All right, very good. So that is a demo. I wanted to show you how to do this CI/CD with blue-green rolling update and canary deployment within the Kubernetes deployment object. You need also the service object to be able to do this. In case of the rolling update, though, you don't need a service object to implement that. You just do the rolling update, and then the system will start rolling them over. In the other ones, you need to deployment, so you need to work with the service object to see how you can direct the traffic to either or both of them using labels. And in the process, I also went through the basic Kubernetes objects, kind of Kubernetes 101 in 5 minutes. All right, so hopefully that was useful. Let me see if you have any question, and then we can take it from there.
Yeah, we don't have any open questions, Damien.
All right, do you have anything to add? Otherwise, I'm pretty much done with the presentation.
Yeah, no, I think this was great. I'm glad to see all that in demo and see how exactly all of that works. I think that was really great session. And Deepa, it was really nice to know testing aspects and rich products your company also has to offer. It's amazing.
I just want to add, it's great that Damien covered this blue-green upgrade. So we have a lot of our clients using XMatters to actually have manage this blue-green upgrade. So if you have like errors in the monitoring, like your service has a bunch of errors, then they use our application to trigger these blue-green upgrades or canary rollouts, right? So do check out on our website of how you can integrate your CI/CD and our XMatters application to manage an automated process. So this is great. Thanks, David, for covering this in detail.
Yeah. And like I said, also just to remind you, all this, everything I talk about here, they're all written in a series of blogs. So if you want to go down to the basics and take it from ground up to where I stopped today, you can definitely go to the blogs. And I can post the link on the meetup page if you want to go ahead and advise them and understand more. So yeah, other than that, I want to thank you guys. Thank you, Deepa. Thank you, Himanshu, and thank you for everyone who is online today. I hope you find this session useful. Again, we're always looking for people to come and share their knowledge. If you're working on some interesting project, feel free to come and share your knowledge with us, and you'll be welcome anytime. And going forward, like I said, we're always going to aim to have two presentations. If no one else is presenting, I'm always here. Even if I travel, because I used to travel a lot, and so I wasn't that active in the meetup. But now we do it online. So even if I travel, I should still be able to, present from anywhere I am. And this is what I do all day, all night. So basically, I should have some knowledge to always share with you guys. So definitely, if we have an external presenter like we have Deepa today, that is perfect. Otherwise, I'm always going to have something that I think you guys might find useful. And at the same time, if you have some topics you'd like us to talk about, things you've been wanting to maybe have a better insight into around Kubernetes and microservices and Docker and all that kind of stuff, feel free to shoot me an email or Himanshu an email, and then or Brent or all of us. So we'll basically take it from there and try to keep the community going. The aim here is to disseminate this knowledge so that people can continue to learn about these new emerging technologies to help them in their job. If you find them useful to go for any commercial stuff, that's perfect. But the aim is just to keep the community going, keep sharing information with each other. All right, so that's it from me. Other than that, our next meetup is going to be in a month's time. It's going to be, I think, September the 16th. And we also have great things lined up. So Himanshu, if you have anything, you can round up.
Yeah, so I think just the one thing, Damien, there is one question, whether this presentation has been recorded and would be available later on. So this particular YouTube link that you're watching is going to be available always. Yeah. So you can refer to it later on.
Yeah, you're right. This will be always available on the link that was sent you. We started the meeting long before we actually started the presentation. So I don't know if we can go and edit it and cut out all that waiting time. But other than that, yes, this will be available for future view and learning as well, for those of you who like to do that.
Mm-hmm.
Yeah.
Cool.
All right, guys. Take care of yourself, and hope to see you again in a month's time. In the meantime, let's keep the community going. If you have anything to share, feel free to let us know. Thank you, Deepa, for coming. Thank you, Himanshu, and thanks to all of you. Good night.
Yeah, thanks everyone for joining us today. Thank you.
Thank you.